I am very, very pleased today to introduce our presenter, Marty Lewis. Since joining Synergex in 2007, Marty has worn a variety of hats as a software engineer or manager for the Workbench and Synergy DBL integration for Visual Studio products. He was instrumental in the delivery of traditional Synergy support for SDI product and was more recently the architect for the new unit testing support for traditional Synergy. He now serves the company as software development manager and works across teams to improve processes and innovate. Let's get started.
Welcome to Recipes for Working with Git. I'm Marty Lewis, a software development manager here at Synergex. So, what is in this presentation? Without getting to talk to each of you separately, understanding your background and your experience with Git, it would be awfully hard for me to tailor this presentation to be useful for each of you. Whether you are considering Git, or new to Git, or an advanced user of Git, I'm hoping to have a little bit here for each of you. We will start off with a little context about how Synergex uses Git. We will discuss some common challenges with Git and how to overcome them. Then on to some general Git recommendations. We also have lined up some tips and tricks that I think novice and experts will both appreciate. And I finally want to discuss with you a tool that may help you solve mismanaged repositories. So, context time. Synergex is still relatively new to Git. We as a company have been in business for 45 years now, and for most of that time, we had either no source control, PVCS, or Subversion, depending on the team. So why did we make the switch to Git? If we have functional source control with long history, why would we change? Well, there are all sorts of great business reasons to change source control systems. Ease of maintenance, better release tracking mechanisms, disaster recovery. But no, the genesis of Synergex's switch was developers. We had a new shiny project, and the developers on that team wanted to use Git because of how well it was supported by DevOps tools. They wanted to wire up Azure DevOps pipelines and releases and utilize pull requests. Developer engagement and workflow became as important as the broader business cases for the push to Git. Sometimes functional is not good enough when you're trying to push forward. Unfortunately, a transition of a system like source control is not always easy. We've got decades of history in PVCS, a source control provider that does not really have a direct upgrade path anymore. We also have accumulated a decade and a half of history in Subversion, which has upgrade paths, but how do we reconcile and combine these histories to get a combined source control repository? Furthermore, what do we do about ensuring that our most experienced developers who are most comfortable with a PVCS workflow can continue to operate efficiently in a new Git world? We eventually found answers to these questions. We built a conversion tool for PVCS so that we could bring across all the history. We merged the Subversion history appropriately, and we built training for our developers that approach Git from their perspective with their needs in mind. So today, we have a presentation about Git tips and tricks because we found ourselves needing to quickly become real subject matter experts. And perhaps maybe we think about Git workflows a little bit differently than your average YouTube video about the subject. Just because we are subject matter experts now does not mean that we do not go back and read the docs for answers from time to time, constantly. Paradoxically, I found that learning about Git means retaining some core concepts and better understanding exactly which doc I should reference when I have a question. I'm sure someday rebasing and edge case reset behaviors will come more naturally, but simply knowing what you want answered is plenty to be proficient. And just because I have a preferred way to solve a problem does not mean it's the only solution available. So now that you understand some of the context for this presentation, Let's dig into some of the challenges and pitfalls of Git. First up, the single most common challenge that I see among both new and experienced Git users alike is a misunderstanding of how all the parts of the Git system work together. It has too many parts when compared to the really simple client-server model of DVCS, and even experienced users may not really understand just how many layers they are working with to tie a whole Git system together. As you've read in the description of this presentation, Git is what is known as a distributed version control system, or distributed source control system. That means its fundamental design is decentralized, allowing any user to easily have a complete copy of the repository and all of its branches, tags, and history. That's a great piece of functionality that increases the redundancy of your source assets even without a robust disaster recovery system. However, that complete copy introduces additional layers of abstraction to every source checkout that can be frustrating or confusing for new users. Your single local source checkout actually contains 3 layers of source control infrastructure without even going into what happens on the remote end. And the remote end is usually some form of Git server as a service, like GitHub, Azure DevOps, Bitbucket, etc., providing access control, commit hooks for changes, and the like. But it does not have to be that. Let's dig into the parts of that infrastructure quickly, because I strongly believe that within that structure are some of the most common pitfalls when using Git. On your development machine, in your clone source, the source code that you work with is called the working copy or workspace. It consists of regular files on disk, but when you make an edit, you can see that the changes are being tracked. You can continue making changes and it continues to live as part of the working copy. And when you switch branches or pull source, your changes in the working copy largely remain untouched unless your changes directly conflict with incoming changes. When you do have conflicts, Git is proactive about letting you know. That's why you will sometimes see that message telling you to commit or stash when pulling a conflict. The files that you stage with git add are put into the staging area. That is the second layer. These changes are uncommitted, but are being prepared for commit. This staging area actually exists in parallel to your working copy. So if you stage a file and then continue editing, the continued edits will not show up in your commit unless you stage the additional changes as well. This is the first pitfall. Do not forget to stage additional changes if you keep editing beyond your initial stage. Otherwise, you are leaving work behind in the working copy. Next, you have your local source control repository, which contains the complete copy of the history and branches. This is the third and final local layer. After you commit your stage changes, they will reside inside this local repository. Likewise, if you do not commit your stage changes, they are not part of the local repository and would not be sent to a remote during a sync operation. This is the second pitfall. Make sure you actually commit your changes, otherwise you're leaving work behind in the staging area. You can continue to work, switch branches, make additional commits, and manipulate your local repository. Those operations will manipulate your working copy and exercise your local repository, but it's all local. Until you do a push or sync, depending on your ID of choice, your changes are still only on your system in your repository. This is the third common pitfall. Make sure you actually push your changes that you intend for others to have access to. Otherwise, you're leaving work behind in your local copy. You really do not want to be the person that forgets to push an important change for a project and end up getting called off hours to come get your work in. Speaking of pushing changes, the remote is the other piece of the puzzle. Since Git is decentralized, there is nothing forcing a given local repository to point to the right remote repository. However, fortunately, we have a convention of all source clones ending up with a remote called origin, pointing back to the Git repository that we cloned from. Users can change this, but generally you don't have to worry about the remote connection unless you have to change where that remote lives. Unless you are doing clones inside your organization from like a static IP, this is usually a non-issue. However, this is the fourth and final basic infrastructure pitfall. Be aware, if you move your main code repository, you need to update all of your clients individually or have them reclone. Otherwise, developers will not be able to push and pull source changes. It's a lot of parts that we take for granted. It's easy to make some of these mistakes, but hopefully by highlighting some of the infrastructure traps with context, you will remember to avoid them. But if you're like me, you will probably still run into them now and then anyway. Beyond basic infrastructure, things can get a little messy. Does your branch merge commit graph look like this one? I sure hope not. Git branches are extremely powerful tools that allow you to compartmentalize your work, facilitate code review, and can help delineate code in development from code intended for release. But powerful tools can also be horribly, horribly abused. Unless you and your team have a solid strategy for when to spawn branches, how and when to merge them, and how to manage conflicts, it's entirely possible to end up with a branch and commit graph looking like this one. This one. So how do you avoid it? How do you keep sanity? That's a great question. And I do not purport to have all of the answers, especially given how different every team and organization may be. There are hundreds of opinions out there on company blogs and vendor blogs, personal blogs, Medium, whatever. They are happy to tell you what worked best for them. But in my experience, the systems that work best utilize one main branch that is the canonical source of truth, with some number of development, feature, hotfix, and maybe long-term release branches spawned off of it. By utilizing one branch as the source of truth, you can always trace the history of the spawned branches back to your main branch, and it should be relatively straightforward to merge work from that branch back in. If you go out too many layers and spawn off of those outer layers and merge changes across multiple layers of branches, it will only cause confusion, and you might get a graph like this one. For some actual examples of what I'm talking about, here are branch strategy flow diagrams for both Git flow on the left and something called Git hub flow on the right. The Git flow organizes the directionality of your Git commits and keeps your work compartmentalized to make it easy to work on new features and next version functionality while still making it easy to support your current release. You spawn a develop branch that lives side by side with your main branch. You utilize that develop branch as a staging and testing ground for the features that your team works on while maintaining the purity of the main branch. That way, if you have a critical issue to fix for a customer in your product, you can spawn a hotfix off of the main branch, make the right fix, get it out to your customers, and then port that change over to your work in progress area. Then, when you're ready to make a release, you can just spawn a release branch off of the develop branch, make any final fixes that are necessary, and merge it up to the main branch. You can, of course, tweak this kind of flow to whatever level of complexity best suits your team. Maybe you want more than one develop branch, but it serves as a great starting point to ensuring code quality and a sane commit graph. I know the diagram does not really show it, but you could also keep those release branches alive beyond that initial merge to main if you're in a position where you need to support multiple versions of your product. So main would continue to represent the latest version of your product, but you may need to merge hotfixes to multiple release branches and make builds that way. The Git hub flow is a very different approach that is lighter weight. It is one that you see more commonly employed on open source products that release straight from GitHub. You still have a main branch that represents the released product, but rather than having the extra layers of abstraction, you spawn the feature branches directly off of that main branch. As long as your feature branches are pretty neatly compartmentalized, or your team is relatively small, this approach works really well. But it starts to get a little messy when any of those features are long-lived and start touching similar areas of the code base. It can be all too easy to end up in a cross-branch merge spaghetti when you and your teammates have competing commits. At the end of the day, the most important thing is that you find a strategy that works for your organization and team and commit to following it. If you can't tell from the previous slide, I'm a believer in the Git flow. While it has some mild complexity that can be hard to work with at first and may have some overhead, especially for smaller product teams, employing a strategy that really tries to bring order to a very complex branch world is something that I can get behind personally. And as a development manager, apparently this is the kind of problem that keeps me up at night. Okay, on to recommendations. Git flow was not a recommendation. It was an example solution for a challenge. Distinction. My first recommendation, don't host your Git sources on premise. Just don't do it. I know. There are security justifications for keeping it all in network, but you do have robust access control when utilizing hosting providers. And you have a lot to choose from, like GitHub, Azure DevOps, GitLab, or Bitbucket, for instance. Don't just take my word for it either. There are some very compelling reasons to utilize a hosting provider. Number one on my list, disaster recovery. Sure, it's easy enough to configure your own systems or utilize commit hooks for making offsite backups of your source code. And you absolutely should. But if your organization actually has a disaster strike, code in cloud greatly simplifies your ability to pick back up where you left off and be productive. Even if you don't quite have product build capabilities the same way, your teams can continue some of their work as though nothing happened. And in an urgent circumstance, you could make a product patch and find a way to get a binary to a customer. This short-circuiting of longer recovery operations could mean the difference between coming through in a tough situation or losing out because of the circumstances. Number two is ease of use and ease of management. Source control providers have built business models and user experience into their considerations of hosting your source code. With a provider, it is very straightforward to control access levels, repository commit policy, control branches, tags, and everything else that you might need on the repository side. They handle the authentication, expiry of privileges, and everything else. And it is so easy to get a source checkout from a service provider. No need to manage an on-prem origin remote or deal with that on-prem origin moving from time to time. Number three on my list is integration. When you use a hosting provider, you are opened up to the wider world of developer tools. It becomes ridiculously easy to integrate pull request process, external automation, problem tickets, support process, or whatever else you need. The hosting providers are platforms of features beyond just your source code. One of the best parts of being a developer using Git is that you have a number of rich tools built around it to augment your work. Like knowing that there's a pull request that you need to review right inside your Teams or Slack. The same can't be said when using DVCS and even SVN without a lot of custom work. Number four is value-added bonuses. Along the same lines as the integration, these provider platforms have plenty of value-added services. If you are in the Azure DevOps space, for example, you have access to build pipelines, which are rich, powerful tools that you can use for driving continuous integration. I think you also get limited access to Microsoft's hosted agent features by default, giving you cloud machines where you can run jobs without a need to configure your own Azure virtual machines or containers. You can use these tools to build up that infrastructure that you need to augment that disaster recovery plan from earlier in this list. Hosting the Git sources yourself is losing out on what the developer ecosystem can provide for you. More tools to make you and your business efficient and successful. My next recommendation is that you get comfortable with at least one GUI for Git. I know a lot of us are used to doing as much as possible from the command line, and that is still a super effective way to work. But becoming proficient with a GUI makes for a much better history and diff experience by default, and can also be a huge help when collaborating with other developers that do not know the specifics of your command line workflow. You have a ton of options to choose from when it comes to a GUI Git experience. The newer experience in Visual Studio is quite nice for a day-to-day workflow and is far less cumbersome than it used to be. You also benefit from full syntax colorization in the diffs when working in this tool, which can help a great deal when making sense of changes. Also from Microsoft is Visual Studio Code. This free lightweight editor has a rich Git experience built in that largely inspired the updated workflows in the primary Visual Studio product. I find its history and change timeline functionality to be a bit less intuitive, but maybe it would work for your style. I'm including Tortoise Git in this list because it and Tortoise SVN are fan favorites for the developers at Synergex. If you aren't familiar with the Tortoise products, their key feature is the integration of your source control operations into the right-click context menus in the Windows File Explorer. You can pull changes, view history, view diffs, stage changes, commit, and push without ever opening a command prompt or IDE. This product pairs nicely with all sorts of workflows. There are also tools like Git Kraken that exist as bespoke tools for Git operations. It boasts rich history views, integration with hosting providers, rich commit graph visualization, and much more. By all means, learn to be proficient with the CLI tools. But even if that is your preferred workflow, keep something on hand to get rich diffs or make some of the harder tasks easier. Just to give an example of what I'm talking about, the Git command line diff actually does a really competent job showing the diff between two revisions. But I had to know the exact revision numbers that I wanted to diff between in order to get here. I had to use git log to get the revisions that I wanted, copy them, and set up the command for doing the diff. To its credit, the diff is actually quite compact and readable. Meanwhile, in Visual Studio Code, we get a really rich source code and diff experience. And in order to get this diff open, all I had to do was right-click on a particular source file, open the timeline view, double-click the revision I wanted to diff against, and voila. As you can see, it's the same diff from the previous slide, and the syntax colorization really makes it pop. And similarly, in Visual Studio, you also get a really clean source and diff experience. And browsing the change graph to diff the files is a breeze. From the Git changes dialog, you can explore the revision graph and then double-click on the file containing the specific differences that you want to view. This is my day-to-day, and I couldn't imagine working without it. Okay. Now that I talked all of you to sleep about problems, branch strategies, hosts, and GUIs, it's time to dig into the real fun. Command line interface tips and tricks. The very first tip is one of the newer tools in my own toolbox, but one that I wish I knew about years ago. It should come as no surprise that Git is a very verbose tool with a ton of options. A feature-rich source control system with dozens of different switches on each tool in order to get exactly the behavior and functionality that you want has to be verbose. It also doesn't help that a lot of those switches have their own shortcuts. So do you learn to memorize the shortcuts to save on keystrokes, or do you type out the whole command every time? Or do you make yourself a shell script to encapsulate the commands that you use most frequently? Like, Am I always going to remember to type out --set -upstream when pushing a new branch out to the remote server? Heck no, I'm not. But I also don't want a bunch of bespoke shell scripts littering my development node or sitting in my path. Fortunately, Git has an answer. Aliases. Git has support for custom aliases built right into the tooling, and the best part is that they support small snippets of script or command execution directly inside the alias definition. So if I want to reference the name of the current branch in my working copy, I can use something like git symbol ref short head to utilize the short friendly name of the branch and execute the command with the right context. So here, on the first sample line, I have now encapsulated my initial push of a new branch to the remote into a nice little shorthand for myself and can execute it anywhere on my system with git PO, or push origin, so to speak. One of my other favorite commands to alias is a hard reset, especially when working with a lot of chunks of coworker code. Sometimes I really just need to hard reset the current branch so I can get a clean pull without thinking about what args I'm supposed to pass. This second alias utilizes the same technique to get the short friendly name of the current branch and execute my reset hard with just the right scope. Now I never need to remember that command syntax ever again and can just call git rh whenever I want to do the hard reset. But you don't have to stop at complex commands either. Anything that you find yourself typing repeatedly and adds up to hundreds or thousands of extra keystrokes over the course of a week or month is a good candidate to alias, like a fetch and a checkout, or doing a poll before you push. Git makes it easy to piece together parts of your workflows into an alias that it's really worth taking a look at the things you do both frequently and infrequently and figuring out a better way. Also, in case you are wondering, you can reference other aliases inside of an alias. So it's entirely possible to cascade a big chain of commands to your heart's content. As for how to define an alias, of course, there's a command line shortcut for defining an alias at either the local in-repository configuration or in your global level system configuration. But the way that inspires the best confidence is to open the global level .git config file from your user profile with your favorite text editor. This file is plain text and should resemble an any file format with section headers and key value pairs. What you see on the slide is an alias section header followed by actual alias definitions. The syntax for aliases is quite powerful, and I think the Git docs do not actually do it justice. So I will provide a link to a GitHub repo that is focused on Git aliases, and that should be included in the resources page that goes along with this presentation. Next up on the tips and tricks is all about diff. As you saw earlier, it's entirely possible to get a pretty reasonable diff experience using the built-in tooling, but IDE diffs give a much richer experience. I will still maintain that an IDE is a really good idea for diffs in history, but there are great tips for getting the most out of your command line interface experience. For example, you are not tied to Git's diff engine at all. The tooling provides opportunity to override the general diff tool, merge tool, and everything about the operational status. As long as you have a command line mechanism for running a diff tool and providing it files, you can use anything else in place of Git's diff. In order to override Git's diff, you must know the right options to override, which I'm going to provide for you. Just like aliases, these settings are stored in your .git config, and there are command line commands for setting these up. However, I find it much easier to configure in a text editor. Okay, first off, let's take a look at what it takes to diff from the command line. We call diff with two revision numbers that have the change that we want to compare. But if we call diff that way, it will show us the diff for every file in that revision. For this case, we're going to call it with just one file name, so we contextualize the diff down to one file. You can see the change in source pretty clearly, but myself and my coworkers really like to work with beyond compare instead. So we're going to quit out of the diff and get to work configuring the diff tool. I already have my config open in VS Code for editing. The first thing that we have to do is define the new tool that we want Git to use. This header, diff tool BC3, if I can get it here for you. This header gives us a new diff tool definition for BC3, or Beyond Compare 3. We are teaching Git where the tool lives and what the argument syntax looks like. You can see here in the command definition, we're using these Git token placeholders for $local and $remote, representing the local version of the file and the remote. These are tokens for where Git will store the temp files that will be compared. Next, we will tell Git not to prompt for the diff tool and to trust the exit codes of from Beyond Compare 3. And finally, we will also tell it that the default diff tool should be BC3. At this point, if we run git diff tool instead of git diff at the command line with the same arguments as git diff, and also if we save our change, our diff will run up in BC3 instead of the command line interface. However, we're not quite done yet. In order to ensure that all parts of the Git process can use our custom tool, we also need to do the same config for Git merge tool. Fortunately, it's almost a copy and paste of the same diff tool config, but we will omit the prompt false. So here we have a copy of diff tool, and now we will make it merge tool, and merge. Great. Now we have a fully configured Git for utilizing an external diff tool. Okay, so now that we have our custom Git tool defined, let's go about making the diff a little bit more useful when working on a per file basis. This is super relevant to our team since PVCS stored all of its commits on a per file basis, and our development team was used to operating on revision history that applied only to one file's timeline. For example, if you wanted to compare the current version of a file against a revision 3 revisions ago, you would type something along the lines of vdiff -r -r-3 myfile.c. I actually think this kind of syntax is super helpful when operating at the command line, and you might see why this could be a hard habit to break. Git revisions, on the other hand, represent a collection of object changes, not just a single file. So when you view the history, you see the progression of commits of the whole source repository, not just one file. Even though Git has its own head -1 syntax for referencing the commit before the current head, that will not necessarily have a change for a particular file. In fact, it is most likely not going to have a change for your particular file. So if you were to git diff head against head -3 with a file path filter, it would report back no changes. Since all of our devs are used to being able to nav history on a per file basis, our own developer Tate Chamberlain wrote a simple script to help bridge the gap. The tool runs a git log under the hood to locate revisions that contain changes to the one specific file, and then applies the same -r -3 syntax to give you a diff in the revision history of your specific file. Let's go ahead and see it in action. So if I come back to my same source area and want to view the same difference that we've been using as an example, all I have to do is tell gdiff that I want to view the difference between my current commit and one revision ago. So -1, and there's my source file. It's just that easy. We get the right diff. This really improves the accessibility of viewing single file history. It's also great for viewing arbitrary points in the file's history. Like, we're not limited to just the current version of the file. For example, we could take a look at the difference between 1 version ago and 3 revisions ago. Different diff. But the features don't end there. If you happen to have, say, one of the hashes for the file, but not the other one, gdiff will also help you out there. It's not just designed to be PVCS-like, it's designed to be Git friendly. So I can say -r and a hash number, and then -r -3 to see the diff between those two things. Now we're comparing an arbitrary hash versus 3 revisions ago. And even beyond that, you could still use Git's head syntax that you could use anywhere else in your Git tools to really mix and match. So if I want to gdiff between, 1 revision prior to the head and 3 revisions ago in this file, I can do that. Beyond that, it also supports tags as inputs, branches as inputs. It's got a lot of great features. I have to give Tate credit on really thinking through these use cases and helping our developers adapt to their workflows. If you are interested in picking up this gdiff script, you can find a standalone source repository or gist or something linked from the presentation resources. All right, this next tip is fantastic and awful all at the same time. Have you ever mistyped a command, especially a git command? Of course you have. Whether you're just typing too fast or your fingers don't want to cooperate, you have certainly had a command go astray. Fortunately, Git has autocorrect. If for some reason you just can't ever get a certain command to type the right way, or you find yourself regularly making errors, you can enable autocorrect with a single command. Following what we did earlier, this will create a help category in your .git config with an option named autocorrect, now set to 1. This enables Git to make best guesses about what you meant whenever you run one of its subcommands. When you typo a command without this set, you can see Git making guesses about what you meant. When this option is enabled, it then just acts on those guesses automatically. You might find it obnoxious, but you may also find it saving you some keystrokes the next time you accidentally type git fetch. Git fetch. Got it. And you can see below, I've got a sample of what that actually looks like when it corrects you. It's pretty inobtrusive. Maybe give it a try. This next tip is my final tip, but possibly the single most useful one if you like a command line centric workflow. The patch option is a switch on both checkout and add commands that seeks to deliver a more interactive experience at the command line. When you use the switch with git add, your workflow can change pretty substantially. If you have a number of files in progress and are adding changes, you can utilize the -- patch switch to run you through the diffs of your changes and let you interactively select which changes should be brought into your change set, and optionally which changes should just be discarded. Gone are the days of checking your Git status and going through each diff individually. Instead, you can let Git present you with each of the changes for your approval. In an IDE, you would probably just click down the list, reviewing changes, deciding which files to stage. This gives you the closest experience to that in a very command line centric way. Git checkout -- patch utilizes the same mechanisms and interactive experience to let you handle merge conflicts during checkout. You can interactively select which parts of the merge should be handled using the incoming hunks, which parts of the merge should be handled using the local hunks, and which parts of the merge may require additional effort. This one weird switch can significantly improve your command line workflow and focus you in on the tasks that you're doing rather than managing your list of files and which ones you have reviewed and which ones you haven't. I'm hoping that among my tips, you found at least one that might help you enhance your workflow. But now we get to move on to a tool that can change your life, at least if you have to do the management of a mismanaged or older source repository. So what is this all about? Well, Git is a great tool that is designed to work a certain way. It's really good at keeping a very long memory and keeping record of the differences between things. But the users of Git will sometimes make mistakes that could be costly from a secret sharing perspective or committing relatively large things that do not diff very well. Suffice to say, Git history will leak secrets. It's super important that you never publish an internal repository or project to a public, externally visible source without careful review. Any tokens, passwords, private URLs, personal details, or anything else that you have inside your Git repository must be considered to be leaked the moment that your repository becomes public. I know it sounds like I'm being overly dramatic or paranoid or whatever, but the reality is that bad actors are listening to the creation of new public repositories on hosting platforms and constantly monitoring for changes that could give them secrets to exploit. And it doesn't matter if your details only appeared in one commit at the very beginning of your source history, that complete history exists and is available from just one clone operation. For my second point, you might not be leaking secrets so much as just causing you and your coworkers extreme pain in trying to unpack large binary blobs and all of their history. Binaries are a really easy way to bloat your archive, slow down your source clone and checkout operations, and generally make everyone miserable. Rather than commit a history of binaries to Git, you should consider storing these in a different kind of archive tool and referencing them externally. But once that binary is already in your source repository, the damage is already done. Sometimes you need to rewrite history in order to deal with these problems. Git does have a tool called filter branch that can assist you in culling details or binaries from history. But it's a very intricate tool, it has a high learning curve, and it also takes a long time to run. Instead, I would recommend using BFG Repo Cleaner if you want a process that just works and you want it to work quickly. But why use a separate tool? Well, the positives of BFG are pretty straightforward. For the use cases that I have outlined, this tool will usually complete the task order of magnitudes faster than Git filter branch. The tool author boasts 10 to 720 times faster, and I believe that figure. I went through this process not culling a small amount of data from the history, but instead culling an entire subsection of the repository from the history. Using filter branch had a runtime of about 16 hours, while BFG accomplished the same task in about 30 minutes. The other upside is that it's dead simple to use. All you have to do is create a mirror clone of your repository. Then you get a few choices of a few easy command switches. You can strip binary blobs larger than 10 megs or 50 megs or whatever threshold you want to meet. You can easily instruct it to delete any file or folders matching a name pattern, or you can even provide it a text doc of secrets that you want it to mask or delete across your entire repository. And finally, it's open source, just like Git. You can look into the way it's built, extend it to meet your needs, and build it yourself if you want to ensure that it's secure. But there are a few downsides as well. Since this product is not included in the box with Git or Synergy or anything else, you might run into hurdles with IT if you have a strict environment. I think if you have a use case that could be benefited from this tool, it is worthwhile to you to get the application cleared for use. The other downside is that it requires a Java runtime. That can also have its own flavor of IT hurdles depending on your organization. For most of you, I think it should not be a big problem. And a third downside is that the tool does not solve even more problems. It is really good at its 2 or 3 primary use cases, so much so that I think it's valuable enough to share with you in this presentation. Where you can find this tool is on GitHub. I will post the link to this tool's repository along with the presentation resources. Speaking of this presentation, what should you take away from it? Well, Git has a lot of history. Yeah? No, I won't quit my day job. We could easily spend an entire day talking about all the tricks, tools, obscure switches, and everything else when it comes to using Git. There's no need to learn all of them, though. I think the key is to continue looking at your workflow objectively and look for opportunities to make yourself more efficient and effective. And then share your favorites with others so that they can benefit from your experimentation. If something seems cumbersome, there's probably an easier way to do it. I would say get used to using Git in your IDE of choice. Even if it's not your primary workflow, broaden your experience. And if you're an IDE only user, learn to use the command line. And finally, be patient with new Git users. The tool has a ton of complexities that take time to master. And if you yourself are new to Git, don't panic and be patient with yourself. There's a lot to learn. Find places to focus and improve and enjoy the learning experience. And with all of that said, thank you for listening. And who has the first question?
We have a question here from Gordon Ireland, which was answered, but I'm wondering, Marty, if you have any other insight to add. He says, what is the difference between Git and GitHub? I use GitHub myself and have worked on projects which use Git and don't see much difference, if any.
I saw that question come in right at the start. I think I probably answered it throughout the presentation. GitHub is a hosting provider for Git. So there's a lot of value-added services there. Git is the underlying tool and technology that GitHub uses. And they both, like, you can get a GitHub client for your machine, but it is still Git under the hood. It just has put its own wrapper on it.
Great, thank you. All right, another question from David Blackburn. He says, do you have a tool to easily convert DBL code in Subversion to Git or GitHub?
It's not a tool that I wrote. There's actually a ton of great resources for this, which is why I didn't end up covering Subversion to Git. There's actually a tool built straight into Git. It's one of the modules called Git SVN that will let you clone an SVN repository as though it were a Git repository. And the result of that is a fully formed Git repository that you could then push to another source. That has a lot of its own options. Like, you can teach it what your trunk and branch structure looks like, and you can teach it how to convert the list of authors, the usernames, to their Git equivalent. That way is really easy, but there's also a lot of bespoke tools out there that build upon it and make the experience even easier.
Great, thank you. I have another question here. It says, we don't have enough bandwidth to use a source hosting provider. Do you have any other ideas?
Don't have enough bandwidth. So that could be a real concern, but generally Git isn't going to consume all that much bandwidth if you're using it from a hosting provider, other than your initial clone, or if you're pulling a substantially large chunk of changes. it's generally not going to transfer that much data. The fetches and the lookups are really lightweight. But if you do have that kind of limitation, you can always use Git locally. You can host your own on-prem. You can also look at. You don't have to completely do away with the benefits of some of the DevOps tools. Like Microsoft provides an on-premise version of TFS that supports Git, so you could always look into that kind of solution for local development.
Awesome. All right. Okay, so a couple of follow-up questions on history. So Kish Bailey says, does the SVN to GitHub tool also convert history? And then a similar follow-up from David Blackburn.
Yes, it does convert the whole history. It will give you all the branches, all the tags. The entire thing comes across the wire. Because of that, the first checkout can take quite a while to run because it has to run through all the revisions. But after that, you can actually use it as a transition tool. You can continue to fetch the updated changes without it being the whole repository. So if you are like work in progress on having some developers get used to Git, but your primary source control is still SVN, you can use it as a bridge. So you can make your commits on the Git side and push those changes to SVN.
Awesome. All right, let's see. Another one coming in. You mentioned collaboration with other developers as a reason to use Git GUI. Why would that matter?
I mean, you could definitely collaborate pretty easily using command line tools, but I have found that in the age of work from home, we're spending a lot more time in screen share sessions for doing our remote collaboration on issues. And the GUI tools just tend to be a lot more accessible. So if I'm looking at a coworker's code and they have some sort of diff tool up on the screen that shows both sides simultaneously, it's a lot easier to get a grasp on it, and the syntax colorization is a huge help. Yeah, the command line diff, you can get a pretty decent experience, but if they're not used to it, or you're not used to their setup, or you do something specific and different, it can be a lot harder to do that collaboration.
Awesome, thank you. Let's see, Steve Ives says here in the Q&A, if you really need a self-hosted solution, I believe GitLab has an on-prem solution, and post a link, so that's very helpful, thank you.
And GitLab itself, the on-prem solution gives you basically a GitHub that lives on site. So you get the experience of still being able to hit that server with your browser to browse changes, browse history, do the user management, that kind of stuff.
Great. Let's see, one more question here. Where would you recommend reading further for improving workflow?
That's a good question. So a lot of what I have found, a lot of the places where I find my improvement is by taking a hard look at what I'm doing and what feels like it's not working well, or I'm maybe doing it the wrong way, and just taking that to a Google search. The number of Stack Overflow or blog posts that you can find that really dig into workflow problems and dig into what Git is doing or what your tools are doing is just off the charts. So don't be afraid to just Google it. If you think that what you're doing seems a little funky, I'm sure someone else has had the same question.